Hello everyone, this is Scaling AppSec through Education. Just briefly touch on who we are, Secure Delivery. Some takeaways from the slide here is that we do this sort of thing commercially, at scale with large companies and small. But it's all built on OWASP projects, and especially built on the OWASP Open Application Security Curriculum, of which I am one of the project leads, together with Toby Irvine. I also lead the OWASP Cornucopia project together with Colin Watson, and I'm currently on the OWASP Global Board. Lots of OWASP there. The real takeaway from this slide, though, is my handle, REWTD, Root Demon, under which you'll find me gooning here on the DefCon Discord. You'll also find me under that handle on Twitter and on LinkedIn. My DMs are open, so please give me feedback on the things that you hear today and the things that you liked and didn't like. Scaling AppSec in large organizations in very little time. Here we go. To start thinking about application security, we have to define it. Let's draw a box around it so that we're clear. Cybersecurity is incredibly broad. IT security covers corporate identity, email security, desktop OSs, server patching, file shares, printers, especially recently, and there's a lot to do there. We're concerned today with the part of cybersecurity you have to deal with when you're building your own software systems. The part of cybersecurity that this village is all about. Your systems can be secure as designed and built, but there are also many ways in how you are building them that can screw you over from a security point of view. Now, someone can push production passwords or cloud API keys to a public repository, or a sketchy person can approach one of the developers on your team outside of work and offer them an eye-watering amount of money to add a little backdoor. A supply chain attack, an open source library that you happen to use, gets some nasty code introduced to it, which you pull it in on the next build of your system. And there are many, many more. We're talking about quality supply chains, of materials, value-add activities, and of design and manufacturing processes. Then what we really mean by application security is product security. Now that's all pretty clear, but security is an intrinsic quality of your system. Sounds a bit philosophical, so let's define that too. This is the ISO IEC 25010. System and Software Quality Model. It's in left to right importance. The quality model is concerned and connected to how a system provides value. So you might think that reliability is more important than performance. But a system with 5 nines availability that's really slow and practically unusable by your customers is completely useless. Now, security sits somewhere on the border between the non-functionals that people care about and they can see, and the non-functionals that people don't much care about and can't really see. Compare, for example, the business impact of a change that was pushed to production that adversely affects performance with a similar change that's pushed to production that adversely affects security. The former, your customers will notice it immediately. The latter, well, something bad might happen, might never happen. But the famous saying, hope is not a strategy. When deadlines pinch or resources get limited, work on these qualities will drop away pretty predictably from right to left, ultimately just leaving functional work and testing. This, in addition to the team simply being unaware of the requirements for a non-functional, is when technical debt starts to pile up. When you hear technical debt, think lower quality. So product security is one aspect of its overall quality. How do we ensure that at appropriately high enough level of security quality while still delivering at the pace required? Now, this is a common way to think about maintaining security, where rapid delivery of changes into production is at one end of a scale and being secure is at the other end. And as an organization, you kind of pick where along that scale you're comfortable with being according to your risk appetites. This makes intuitive sense to us because as humans, we perceive moving quickly as carrying more risk, like driving a car with your foot down. The problem with this intuition when applied to application delivery is that it's completely wrong. I'm not saying rush everything and it'll be fine, but rapid delivery and high quality are not opposed to each other. In fact, they complement each other. Having the ability to develop and release change to production quickly means that you can improve things quicker. You can find and fix issues quicker. You can find and fix those security issues quicker. It means you have automated deployment processes, which remove human error, removes opportunities for malicious intent, and increases the reliability of your ability to actually deploy. If you have automated testing processes, then you're increasing your functional correctness, and you'll also be increasing any non-functional qualities that you're directly testing for. Think of performance again, hopefully security. You've probably got code that's clear and straightforward to extend, and you're not handing off changes to other teams for assurance or for deployment. You simply can't deliver at pace unless you're paying attention to the non-functionals. Performant, interruptible, reliable, usable, maintainable, and secure systems can be changed with confidence. Low-quality systems are harder to change. They're brittle, unmaintainable, unreliable, insecure, slow. These low-quality systems can't be changed quickly. They'll functionally fall apart if you try, and everyone is quite correctly far too scared to try. Every change leads to unpredictable failures and overly complex systems. The slowest release cadence projects that I've worked with have all been the lowest quality, the worst designs and terrible code bases. Delivering slowly isn't more secure, it's fearful. And if you're afraid of changing a system, then that system is not secure. Taking all of this into account, a security incident is a trailing indicator of low software quality. Problems set in long before that incident happened, right? Trailing indicators confirm long-term trends, but they don't help us to predict them. They're a terrible measure to base your organizational decision-making and budget allocations on, which is why a massive internal rebudgeting and shake-up in response to security incident is usually a bad idea. So how do we manage security quality when the only thing we have is a trailing indicator? Well, we need to get some leading indicators of software quality to get ahead of any potential incidents. If we had leading indicators, then we have good measures to base our decision-making on. The leading indicators that are used to define high-performing teams are the 4 metrics that matter. So high-performing organizations derive more value from high-quality software delivered by their high-performing technology functions. Analysis by Nicole Forsgen, Gene Kim, and Jez Humble in 2018 in Accelerate shows that there are 4 metrics that are strong leading indicators of high-performing organizations. They are lead time, deployment frequency, mean time to restore, and change fail percentage. Notice that functional correctness doesn't impact any of these, right? You could build a completely wrong system, make no money, mess up your customers, with extremely high quality, if you like. So getting the functionals right is still important. But non-functionals do impact all of these. Security is interesting, though, because improving the security of our systems doesn't improve any of these metrics, except insofar as we also improve the other non-functionals. How we improve product security can make these metrics worse, though. We need to aim for as minimal an impact on those metrics while improving security. And that's why tracking these 4 metrics is important for security. So if we're measuring these 4 things in delivery, then we have direct indicators of the underlying non-functional qualities of our system. If these are trending badly as a team, you're not paying enough attention to the non-functionals. If these are trending well, then your current balance between getting features out the door while maintaining the quality of your work is sustainable. To hone in on specific measures for security, we're going to need something more, though. So in this study of the root causes of all CVEs reported in the 8 years between 2008 and 2016, says that almost all are in code, right, in the implementation section. This makes sense because there are only so many ways that you can screw up a design or configuration. But there are countless ways to screw up while coding. It's extremely complex. Traditional focus, cybersecurity, design reviews, configuration, hardening, sys, that sort of thing, sits in this area. It's useful, but it's far from the whole picture. So if most of product security lies in preventing security defects in code from reaching production, and in fixing the ones that are already there, and having a measure of direct security defect density in code from a security testing tool is a good direct metric for security quality. Lastly, we've seen that how we're building a system also affects the product security quality. So we need some measures of that. So what are the activities that have positive effects on quality generally? Well, let's go through the ways that you would ensure performance in your systems first, as it's more familiar, and then we'll take it from there to security. Firstly, we'll think about the performance impact any change might have while we're planning for it, right? During sprint planning. We'll plan our overall system architecture around it being performant. We'll make sure that it is performant. We'll ensure that everyone on the team knows how to write performant code, using the languages and the frameworks that need to happen. We'll hire people with domain expertise in performance to come in and coach and guide our teams and the wider business to understand how important performance is. We'll peer review code changes for those inevitable human errors that slip in that might impact how performant our code is. We'll share known performant code and internal libraries across the teams. We'll make performance a key consideration in the selection of any third-party libraries or third-party services that we depend on. We'll automatically test all changes for performance regression on every commit to develop so that developers can catch things quickly and catch them early. We'll prioritize performance fixes that are on our backlog or in the development cycle. And we'll inject comprehensive telemetry to measure and monitor performance in production. We'll investigate any performance incidents we have in production, and we will widely publish the findings. And we'll have responsibility and accountability for performance. We'll sit with the team, with the people building the systems. Now, you've probably already guessed what the big reveal is going to be here. That's right. It's similar across all of your non-functional qualities, right? So security is going to fit in exactly the same place. Now, some of this we can measure and make visible, like we can have a record of developers who've had secure training. A team with only developers who haven't had it is much more likely to create a system with low security quality. It's a given. We can check GitHub and GitLab for evidence of pull requests and reviews to show that peer review is actually happening. Now, we can't see that it's for security, but we can still see it is happening. We can check Jira or whatever work tracking system you have for the age of items that have been marked as security work to show that known issues aren't being deprioritized, they're not being ignored. And we can check the build and test logs on our orchestration platforms for evidence of the security tool test runs. And we can pull all of these delivery metrics, direct code level security testing output, and evidence of good ways of working together, create strong indicators that we have a product security under control. But how do we wrap this up in a scalable process that ensures security is at the level that it needs to be at while still delivering at pace? We take a page out of site reliability engineering, right? We have some experts in the field that build self-service platforms. It's important so they get out of the way, and then provide us with launch engineers that work closely with the product teams to make sure that it hits the ground running. It has all the things necessary to be reliable. Service level objectives, well, it costs a lot more to run a 5 nines reliable system than a 2 nines reliable system, right? It's the difference between 7 hours of permissible downtime to just 26 seconds. So agreeing what the product requires is fairly essential. Service level indicators are relatively straightforward for reliability, right? Is the system up or down? How long has the system been down for so far this month? The operating model is simple. It's data-driven, so there's no emotion. It provides a self-regulating back pressure on the product team if they let reliability go down with whatever changes they've made to the system over time. A product team that has production support responsibility handed back to them then has a strong incentive to now focus on getting reliability back to where it needs to be. SRE won't take on production support again until reliability is demonstrably back to the agreed level. means that developers are not building new features because they're spending time doing support. And they don't particularly like being woken up at 3:30 in the morning either. Can we apply this method to security? Product security engineering. So you can map SRE to security. It's the same, just making security part of the engineering function. Now it's an adjustment for some security teams to become that internal consultancy with an education focus, who are building pipelines and making sure there's automated tools in place. But others are already doing this, right? A lot of organizations are already doing it. And a lot of those organizations are also already grouping systems based on criticality with greater security requirements on those critical systems. So they need to specify where the security level indicators need to be for each group, but they're almost there already. Now, we don't have one clear service level indicator equivalent, so we're going to have to combine multiple indicators to create a composite SLI, as you've already seen. Now, best to provide that back pressure is going to vary from organization to organization. We've made security visible through SLIs, but without meaningful back pressure, the product teams can't self-regulate for security. Unlike reliability, you probably aren't going to get a series of smaller security incidents leading up to a big one, right? Failure mode security is immediate-ish, not gradual. This month, we've been hacked twice briefly already. We need to ease back on feature work and work on security so we don't get hacked anymore. It's unfortunately not a realistic situation. So strong incentives for product teams need to be in place to keep leading indicators where they need to be. They're essential to avoid security quality deteriorating, which will lead to sudden critical failures. You need to be able to answer the question, who's contributing to the system, code, design, product decisions, what subsystems make up the system, what components make up those subsystems, which code repositories map to those components. From the bottom up, you need to be able to go from source code repository that might be demonstrating a problem to the components, subsystems, and systems that are built from that repository without asking people. People come and go. Software tends to stick around probably longer than it should. If you can't do this from an engineering point of view, the organization has zero chance of getting its act together or being able to build high quality secure systems or respond to identified problems adequately. And evidencing to regulators that things are under control will be very hard. Proving there's been no negligence in the event of a security breach will be next to impossible. Security level objectives can be as simple as comprehensive as your organization needs, and automated to the degree necessary to scale to the size of your organization. This is a representation of a system that security delivery previously built for a large organization. It's heavily automated, integrated with multiple other systems such as Active Directory, HR for training data, their EIM system, GitHub Enterprise, with a composite security capability score calculated by an algorithm which factored in all the security level indicators identified as important to the bank. The SLO system itself exposed an API for automated deployment or change control systems to check that the product and its team were currently in good standing to allow for rapid deployment to production. Now, you may not need all this, but the act of gathering requirements and establishing the baseline is very valuable and brings all stakeholders in your organization together to agree on the right balance and the approach to security quality for you. We're all competitive. No team wants to be the worst performing. Quality assurance activities have to happen. So if a delivery team does them and evidences them, they can go straight to prod. The carrot, right? Fast track to production. If they don't, then someone else will have to do it, and that takes up a lot of time. As we saw earlier, you have to get the right operating model to acknowledge the aspects of product security explicitly, to measure them, and to make the right people accountable. So, there will be many talks. There have already been many, and there are more to come on most of the rest of the slide. Today, I'm going to focus on the part in bold, mostly because I know that without developers learning to write and then continuing to write secure code, we cannot hope to succeed. My talk for OWASP at BlackHat EU last year was on exactly that topic. RUBFG, red unless blue finds green. So I'll leave the why as assumed for this talk, and I'll focus on the how. But feel free to check out that talk afterwards if you disagree with that premise, and feel free to comment and give me some feedback on it as well. So this brings us to secure software development training, the how of it all. Today I want to talk about our latest, our being OWASP's latest attempt, because this isn't the first time we've tried it, to standardize and codify a curriculum for secure software development. This is an OWASP initiative. I'm a huge fan of OWASP, especially of the open source approach to building stuff, because then things happen in the open and anyone can contribute. It also makes sense to use the OWASP projects that set the standard for measuring software quality, which is the ASVS, and deployment maturity, which is the SAMM, and to use the great work that's been done on these. We also leverage Cornucopia, because that leverages those same projects as well and covers design principles, and the top 10 because that's where everything starts. Speaking of starting, let's kick this off with the fundamentals, the top 10. The top 10, although there are now several, is where most teams start to look at product security. That's from the common defects side rather than how to build things right. But the original top 10, the one that's being updated this year and is referenced indirectly now by the PCI DSS, despite not being a standard, is still a good place to start. Andrew Van Stock, who's the current top 10 project lead and executive director for OWASP, said at this year's Developer Summit that the top 10 is a good place to learn to crawl from. So here we begin. Briefly, the top 10, because there are full presentations of the top 10, and heck, I even have a couple myself, are currently the items on the right of this table. Those on the left are from the previous version, which was released 3-4 years prior to this one was. As you can see, the changes are fairly minor, right? 2 got dropped because framework changes corrected the bulk we previously saw. 2 got merged. They're actually fairly similar. 3 got added. 2 of those via the then newly added community update created by the AppSec professionals who found that these were important. They are important, and at the time data was hard to find on them. Broadly, top 10 populates 3 areas: validation issues, access issues, build issues. And by build, I mean makeup or composition here. So education on the top 10 tends to cover these 3 areas to greater or lesser degree, using examples, possibly demonstrations, and then talking through code samples and showing how you can fix it in the code and how those issues can be uncovered, discovered, and fixed, remediated. That's exactly what the ASC 101 or ASC Foundation covers. This is who it's aimed at, all of product delivery from product owner right the way through to engineers. You don't need to know anything going into it. It is a foundational. It's the basic entry level here. And it'll cover the top 10 and the basics of AppSec. It comes with a slide for each of the top 10 and speaker notes based off of the expert experiences of the guys who contributed. And it can be found right here. Just a quick special thank you to HMRC, Her Majesty's Revenues and Customs, the UK Tax Department, who helped build this piece of work and then contributed back to OWASP. Taxpayer money paid for this. Thank you very much, folks. But what comes after that? What are the next steps? Cornucopia, of course. Because architectures are evolutionary, and Cornucopia allows developers to use the knowledge they learn through the game to evolve the thinking about threats through modeling, perhaps. As the architecture evolves, we choose Cornucopia. It's perfect for it. Cornucopia itself stands on the giants that follow and kind of simplifies those more complex structures and the top 10 as well. And it creates a top 5 places to consider doing either a user story or a user security story or a security spike, or adding security NFRs to existing stories, or acceptance criteria for security in existing stories. Cornucopia, in case you don't know, is a card game. And it's based off of Adam Shostak's EOP, Elevation of Privilege. Now, EOP covers gamification and gamifying threat modeling for security folks, while Cornucopia does that for developers. The point of view shifts just slightly. Now, I have hours of presentation and demonstration materials on Cornucopia, And Adam and I have done a panel where we go back and forth on the relative merits of gamification and on the different tools that we can use for that. But if you want to learn how to play the game, then watch this video. And then reach out to me to get hold of a deck. I have a couple of decks that I can share with the first group of people that reach out, or for beta access to the online version that we're currently working on. Again, I have hours on these, so I'm going to just zip through the slides very quickly. Cornucopia, or the OWASP Top 5, is made of 6 things. You'll see why in a second. Those 6 things are Auth N, who you are; Auth Z, what you're allowed to do; session management, the how and how often we check auth; cryptography, which is the secrets, the hashes, and the poor choices. You know what I mean. Come on. Anyway, moving along. Data validation and coding, which is making sure that anything that crosses a security or a trust boundary is safe. And then a catch-all, because stuff doesn't always just work out. It never fits nicely. So how do we use Cornucopia as an educative tool? Well, we play the game. Actually, as a security person, what you do is you teach developers the game and give them the materials that come with the game and then let them play on their own. Otherwise, it's a little bit like playing Cards Against Humanity with your parents. Then to cover off the do threat modeling checkbox, you have the devs tag the stories in Epics and Jira, and you have them scan in their score sheet. And that gives your auditors something to feel warm and fuzzy about. Well, you and the dev teams know that things are being done right. But how do you level up from that? Well, there are 2 possibilities, and this is where most of the work is still happening. We are, to begin with, wanting to make secure software development a skill that developers can gain while learning to code, or learning to code right, or learning the right coding patterns. Most of us start fairly young. My 11-year-old is quite happily building software. And so we're targeting, in this case, the tertiary education area, with an eye to group skills into modules and then stack those modules up to cover the whole of this build a secure things space. How does it work? Basically, well, the ASVS is OWASP's answer to the question, what is the standard against which software can be measured for security? Because, well, it is a standard. And as a standard, it has gone through a lot of rigor and scrutiny. Although perhaps never more so than when we decided it would make a good basis for the curriculum. The 1,000-foot view of the ASVS, in case you've never heard of it. The first thing you need to know about the ASVS is that it's split into 3 levels, each applicable to different types of applications. Level 1 should be used on all apps, and it can be tested for using DAS tools alone. Zap is a great way to test level 1 OWASP Zap. Take a look. Every app should probably get tested, though, to at least level 2. The problem is when you go beyond level 1, then you need to look at code, you need to review some designs, you need to have conversations with the developers to get full testing in. Level 3 is for apps that are serious about security. If your app manages special categories of data or connects to systems that do that, think bank accounts, patient records, etc., then you should be looking here. There's also technically a level 0, which is what any application assessed that didn't meet all the requirements for at least level 1 is tagged as being. If you use level 0 in your organization, you probably want to document what a pass meant for you. Learning areas for the ASVS cover everything from architecture, which is not tested during level 1, through to details about configuration, which is incredibly tested during level 1, and includes the domains from Cornucopia earlier, right? Authentication, access control, authorization, session management, validation, cryptography, many others. To assess to level 3 across all these domains is to cover off 286 requirements. So how do we break this down for teaching then? Well, we break all the ASVS requirements into actions and terms. We group the terms into units, and then we weigh the actions described against Bloom's taxonomy. Bloom's taxonomy, or more accurately, the cognitive domain of that taxonomy, describes 6 levels of learning, from remember through to create. It's a standard applied by educators around the world, and being hierarchical, in order to successfully understand, you also need to remember. So remember first, then understand. In order to apply, you need to remember and then understand and then be able to apply it. Now, while 6 is theoretically possible, we've not found cause to use it in the ASC yet. We've also not seen anything less than a 2. It's interesting to note. The process is as follows. We take a requirement from the ASVS like this one. We identify the actions. We identify and collate the terms, and we apply magic to determine the Bloom's level required to fulfill the requirement. That magic being a fair amount of experience with assessing against the ASVS standard or building software that met those requirements of the ASVS standard. This results in the basis of the curriculum though, right? What knowledge is required to build something that meets the requirement or to evaluate whether it does meet this requirement? Obviously, the next steps from here are to find information on each term, make a note to the standards authors about the item, or maybe even add a knowledge-based article or some combination of the above, and then actually build teaching materials from those terms, which would be grouped by units. Curriculum may not go to that degree, but we have done it with the first section. This particular requirement actually does have a note back to the ASVS team, and it also has a to-do item, a thing that needs to be done, because we don't have an article on a feature-based approach for modeling role-based access control. But there is somebody who's written a paper on it, and that's a good source to start at. Now, although we covered off ASVS in the tertiary section, everything gleaned there can and must also become available through industry training, as with everything discovered in industry training should eventually end up in the tertiary education section. So imagine that all that previous work would also be broken up into parts that can be consumed in 1, 3, and 5 day increments, grouped together in job-shaped courses with related modules rather than the units previously described. It's all still work in progress. In this section, we're going to cover OWASP SAMM, where ASVS is about building a secure thing, SAMM is about building a thing securely. When it comes to telling folks how they should build software securely, you need it to be prescriptive, which is one of the reasons we picked SAMM over, for example, BSAM. The other is, of course, that it's an OWASP project, and you may have noticed how much we like those. SAMM is made up of 5 business functions. Each business function is a category of activities that organizations involved in developing software somehow perform. Each of those functions has 3 security practices, which are group-related security activities that support them. Security practices have 6 activities grouped in logical flows, divided into 2 streams, and split across the 3 maturity levels, giving us 90 requirements in total. Streams cover different aspects of a practice and have their own objectives, aligning and linking the activities in the practice over the different levels. Now, the learning areas in SAMM cover activities from overall governance and education, hey, that's a thought, through to operational concerns like managing incidents. As before with the ASVS, we break down the activities into actions and terms and then go through the weighing process. There are fewer activities in SAMM than requirements in the ASVS, yay, but the activities are more complex. Damn. We follow the process from before, but this time gathering actions from a given function, function/practice/stream for a given maturity level, as you see at the top there. And we group those actions into modules, and then the rest becomes identical. Applying this in practice though, how do you get hold of the curriculum? Well, foundations, it's easy. Just go get it. ASC 101 is available on the OWASP website, on the Application Security Curriculum page that was linked earlier. Go grab it, teach it to your teams, or have us come in, secure delivery, a bit of a pitch here, and we'll present it to your teams. We leverage other tools like Secure Flag, which is another OWASP project, and commercial tool, and we make it live for your devs. We give them hands-on, actually break this application by exploiting it using that vulnerability, then show you where the vulnerability is in code, and then help you to work out how to fix it. Intermediate training, use the game with your teams. Reach out for a deck of cards, again, at Root Demon, or reach out to us for beta access to the online version, or have us come and play with your teams and have us teach them how to play. Tertiary and industry training is still a work in progress. We've built parts of the whole, and we're able to present those parts to your teams if they have a need for particular aspects of them. But that's not the point, right? The point is for this to become a standard and for everyone to have access to it, all of it. So we'll continue to build out what's there until that is the case. Future? Well, help us to complete the mappings, to work on building the modules and units, and then possibly even creating slideshows and speaker notes. Sponsor the project, like HMRC has by engaging us, or through the OWASP grants process that's listed here. And most importantly, give us your feedback. That's my OWASP email address there, along with my Twitter handle and, of course, my Discord handle. Reach out to me here if you want to as well. One last thing. There is a survey by the How to Get into AppSec project, a sister project to the curriculum, which also falls under the OWASP Education Committee. Now they're doing a survey to get details of AppSec roles around the world, and the survey is going to be used to create destination personas, endpoints in the journey into AppSec. And of course, it'll provide us with a basis to build out the job-shaped courses and those related modules that we need to do. With that, I'd like to thank you very much for your time, and I hope you've gotten a lot out of today. Again, feel free to reach out to me any way you like, any of the options that were available to you, even through the feedback channel here. With that, I wish you a fantastic day.